Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. Of course, I'm Miss McGuire. Today, we're going to be doing the last lesson of the semester and Unit 3. Today, we're focused on Unit 3, Lesson 12, Part 2 of Solving by Completing the Square. Please make sure that your notes, include your first and last name, the period, and the date in the top right-hand corner. Today's objective is I will solve degree 2 polynomial functions by completing the square. And then we're also going to do some real world modeling at the end of the lesson as well. We're going to add a little something extra to what we've been doing. So in example 1, we're going to dive right into solve by completing the square. I've got the same steps that we used in lesson 11. So this part of the lesson isn't new. It's totally a review. Let's go ahead and walk through part A together. So part A, y equals x squared minus 4x minus 2. So first we want to make sure that our y value is 0 because we're solving for the zeros, the x values that make y 0 in our function. So remember, we want to isolate the ax squared and the bx terms on one side of the equation. So to do that, I'm going to just add the 2 to both sides. And that way I'll get 2 equals x squared minus 4x. And now the ax squared and the bx terms are alone. Now we need to find the new c value using b over 2 squared. So we're going to take -4. Our b value is -4. So we're going to take -4 divided by 2, and we're going to square it. So -4 divided by 2 is -2. -2 squared is +4. Now I'm going to add that new c value to both sides of the equation. So we are going to have, I'm going to use a different color for c, 4 plus 2 is equal to x squared minus 4x plus 4. All right. Now we need to factor the ax squared plus bx plus c side and then rewrite it as a perfect square. So 4 plus 2 is 6 equals, and now we're going to factor this. So to use a little, faster way of factoring, I know I want both factors to be the exact same, so I can write them as a perfect square. So I know that they have to be the same, which helps me. I know that this times this needs to get me x squared. X times x is x squared. Then I ask myself, what times itself is 4? And that's going to go in the second spot. Well, 2 times itself is 4. So I'm going to use 2 and 2. And then the thing I need to watch out for is this -4x in the middle. Because I need to get -4x when I multiply this out, I want to make sure that both of these signs are negative. X minus 2 times x minus 2. And the reason why is because that -2x and that -2x will simplify to -4x. So watch out for those signs. All right, so I'm going to rewrite this as x minus 2 times itself is x minus 2 squared. Then the next step is to square root both sides. So we're just going to take this function and we're going to square root both sides. Now remember, what happens when you square root a square? If I square root a square, it cancels itself. So I'm left with x minus 2. On the other side, when I square root something, I get 2 answers technically. I get a positive and a negative. So I'm going to have plus or minus root 6. Then step 5, solve for x and simplify both sides of the equation. So we're going to solve for x by adding 2 to both sides. I always want to write the integer first and the radical second, so that positive 2 is going to be written out in front of the plus or minus root 6, and then I have equals x. I could flip that around and say x equals 2 plus or minus root 6 as well. Then of course, because your teacher's so extra, we got to write our answers as x-intercepts and zeros. So my zeros are x equals 2 plus or minus root 6. And my zeros are 2 plus or minus root 6, 0. All right. So why don't you go ahead and do part B on your own? Now, here's the thing I want to point out, though. to be able to complete the square, your a value has to be 1. So if you look back at all the examples we've done as a class so far, our a value was always 1. There's technically a 1 here for a. For this one, the way it's set up, negative x squared minus 9 equals 8x, a would be negative. Well, one thing I need to notice is that I need my x squared and my x term on the same side of the equation. How could I make my a value of negative 1 become positive 1? Well, what if I added x squared to both sides? If I do that, I'm going to end up with negative 9 is equal to x squared plus 8x. And now I finally have my a value as a positive 1. And then we can go ahead and finish completing the square. So why don't you go ahead and do the rest of the steps and solve by completing the square. Press pause and then press play when you're ready to check your work. All right, so I found my new c value by taking b, or 8, dividing it by 2, and then squaring it, which got me 16. I added that 16 to both sides of the equation, of course, because what you do to one side, you have to do to the other. 16 plus negative 9 is 7. I factored x squared plus 8x plus 16 to x plus 4 times x plus 4. So I got 7 equals x plus 4 squared. Then I square rooted both sides. By square rooting, the square cancels and I'm left with x plus 4. And then equals positive or negative root 7. Then I subtracted 4, so the x would be alone. So I have x equals negative 4 plus or minus root 7. Then for my x-intercepts, I have negative 4 plus or minus root 7, 0. And for my zeros, x equals negative 4 plus or minus root 7. All right, let's keep going. So in the next problem, we are going to be writing the degree 2 polynomial given the zeros. So instead of solving for them, we're actually given them this time, and we need to find what the original equation would have been. So again, this is a review of what we did in our last lesson. So it's not as new this time. We've seen it once before. So our first step is to take each 0. So we got x equals 1/3 and x equals negative 3, and just set them equal to 0. Or set them equal to x, sorry. What am I saying? Then we want to make each one equal to 0. So I get x equals, okay, so x equals 1/3. Because this is a fraction, before I even do the next step, I actually want to get rid of this fraction just to make my life easier. So I want to get rid of this denominator. Well, doesn't a fraction bar really mean divide by 3? So how do I cancel divide by 3? What if I just multiply both sides by 3 real quick? Well, if what I do to one side, as long as I do to the other, it's okay to do that. So I'm going to get 3 times x is 3x equals 1/3 times 3 is just 1. Then to make it equal to 0, I would subtract 1 to both sides. So then I get 3x minus 1 equals 0. Then for the other one, I have a negative 3 here. So I'm going to add 3 to both sides. I get x plus 3 equals 0. Now we rewrite as factors in the same equation. So remember, this is one of my factors and this is one of my factors. So 3x minus 1 times x plus 3. And I want that equal to 0 because I'm writing an equation. Then we replace 0 with y and then multiply the factors out. So we're going to have 3x times x, 3x times 3, negative 1 times x, and negative 1 times 3. Combine like terms, and we get 3x squared plus 8x minus 3. And we've written the function when we were first given the zeros of 1/3 and negative 3. So if you solve this function, you should end up with the zeros of 1/3 and negative 3. All right, let's do part B. So why don't you go ahead and try part B on your own? You're given the zeros, x equals negative 3/2 and 5. So remember, set them both equal to x and then make them equal to 0 from there. So I would, as a hint, just get rid of that divide by 2 to make your life a little easier. All right, go ahead and press pause and then press play when you're ready to check your work. I'll see you in a minute. So the first thing I did was I multiplied both sides of this thing by 2. So I got 2x equals -3. Then I added the 3 to both sides and got 2x plus 3 equals 0. So I put that in one of my factors in the equation. Then I just subtracted 5 to both sides and I got, oh my gosh, I messed up. That's silly. I got x minus 5. Why did I write a 2x? That's so silly. So I got x minus 5 here and that one here. So that means my final answer is wrong. So now I need to multiply it. I made it harder than it had to be. Oh my gosh, that's so annoying. Oh well, at least I caught it. Sometimes I catch my own mistakes, I guess. So y would be equal to, let's see, 2x squared minus 10x plus 3x minus 15. So when I combine like terms, I'm going to get 2x squared minus 7x minus 15. Thank you for your patience on that problem. All right, so hopefully our answers match. If not, let me know in the chat. We'll try to figure it out. All right, so now we're going to do one of the fun parts of solving quadratic equations. We're actually going to do a little bit of modeling with quadratic functions. So you can do some pretty cool stuff with parabolas. And one of the best ones is actually modeling the path of a rocket. So if you were to pretend like this is the ground, okay? If you were to launch a rocket, so like here's a rocket, and you launched it, its flight path takes the shape of a parabola before it hits the ground. So if you picture this like a X and Y axis here, your rocket then, as it takes flight, has an x-intercept of where it was on the ground originally. It goes up, makes this parabola shape, and then eventually hits the ground again. And where it hits the ground over here is another x-intercept. Now, up here then would be its max height, the highest that that rocket went. So we can actually use our quadratic formula and a quadratic function to find a couple things. We can use the quadratic formula to help us find the time when the rocket actually hits the ground. We can also use it to help us find how far the rocket went. And how high the rocket went. This would be the distance. So we can also find the max height. We can find this point right here. So I'm going to walk you through how to find the max height and how to find the time for when the rocket hit the ground, and then how far the rocket went as well. Or actually, we're not doing how far the rocket went. Sorry. We're just doing the max height, how long it took to reach that height, and then how long it took to hit the ground. Okay, so the way you find this information, first of all, when we talk about height as a function of time, your equations are going to look like h equals a times t squared plus bt plus c. So instead of using y and x, we use t as our x values. So we're going to say like our t-intercept instead of our x-intercept. So your x-axis represents t as in time. Then your y-axis represents the height of the rocket, or h. So in this case, time is a function of height, or height. Sorry, I said that backwards. Height is a function of time. I'm silly. So let's go ahead and jump right in. So to find when the rocket reaches its max height, you take t and you set it equal to -b over 2a. So to find t when our rocket hits its max height, this point right here, you use -b over 2a to find that time. So you're looking for t and h. Then to find the max height, you just plug in t equals -b over 2a back into the function and then simplify for t, or sorry, simplify for h. So you plug t equals -b over 2a into the function. Or you find, another way to say that, like mathematically, would be you find h of negative b over 2a. You plug whatever we got in here into the function and then simplify for h. All right, then to find where it hits the ground, you can solve multiple ways. You can use factoring if you can. You can use the quadratic formula. You can use completing the square. But what we are going to do is we're just going to use the quadratic formula. So you're going to use t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So notice instead of using x, I'm just using t. Otherwise, the quadratic formula stayed the same. So let's jump into our first example. So example 3. Campers of an aerospace camp launch a rocket into the air. The path of the rocket can be modeled by the equation of, so our equation is h equals negative 16t squared plus 150t plus 1, where h is the height of the rocket in feet and t is the time. So when does this rocket reach its maximum height? So to find when it reaches its maximum height, we use this equation. T equals negative b over 2a. So the time it reaches its maximum height is t equals negative b over 2a. So in this equation, our a is negative 16, our b is 150, and our c is 1. So a is the coefficient of t squared, b is the coefficient of t, and then c is your constant. So we plug in our b value of 150, and then multiply 2 times our a, which is negative 16. So the negative of 150 is negative 150, over 2 times negative 16 is negative 32. Then I know that a negative divided by a negative becomes a positive. And then 150 divided by 32 is 4.68. Or why don't we round it to 4.7? So 4.7. So the rocket reaches the max height at 4.7 seconds. Because we're talking about time in seconds. Now we need to find the rocket's maximum height. So the rocket's maximum height happens at 4.7 seconds. So all we have to do is plug in t equals 4.7. So you take the equation, h equals negative 16 t squared plus 150 t plus 1. And you just replace t with 4.7. So our height, our max height happens at, let's see, 4.7 times 4.7 is 22.09 times negative 16 is negative 353.44 plus 150 times 4.7 is 705 plus 1. So 705 plus 1 minus 353.44 is 352.56. And of course, we're talking about height in feet. So this is 352.56 feet. I should have circled my last answer. So now, of course, we always write our answers in complete sentences when we talk about word problems in this class. So the max height is 352.5 feet. 56 feet. I guess I should have rounded that to the nearest tenth, like I rounded the other one. So let's do 0.6. Okay. Now, when does the rocket hit the ground? So remember, to find when it hits the ground, you just use the quadratic formula. So you're going to use t is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So our A value is, sorry, our B value is 150. Our A value is -16. And then with C1, yeah. So let's start simplifying. So our T is equal to the negative of 150 plus or minus the square root of 150 squared. It's 22,500 because I can read numbers. 4 times 16 times 1. 16 is 64, right? And a negative times a negative is a positive, all over -32. I'm going to go ahead and work across since I don't have enough room to work down, even though I don't really like it when we do that. We're going to add that to 22,500. So we get T equals, this is equal to -150 plus or minus the square root of 22,564 all over -32. Now, when I talk about time, do you walk around saying, hey, I'll be at your house at -150 plus or minus the square root of 22,500 plus 64 all over -32 seconds o'clock? Like, that's not how we talk about time, right? So it doesn't make sense to describe time like this. So we're going to change it to a decimal so we can actually understand what this means as a value of time. So what we're going to do is we're going to go ahead and split this into 2. So our time is equal to -150 plus the square root of 22,564. I'm having trouble with that number today. Divided by -32. And then T is equal to -150 plus or minus the square root of 22,564. Sorry, I want to do the minus one. So minus here, all over -32. And we're going to simplify both of these and then see which one makes sense within the context of this problem. So, all right, I got my calculator open. So we're going to take negative, so negative sign 150, and we're going to add the square root. So I'm going to do second square root, 22,564. I'm not going to say that number right on the first try today. We're going to hit enter, and then we're going to divide by -32. And we get a negative 0.0066, so 0.007. Then for the other one, we're going to have -150 minus the square root of 22,564. And we're going to divide by -32. And we get T equals 9.38. We'll go 38. So here's the thing. Does it make sense to say that the rocket hit the ground in -0.007 seconds? Is it possible for negative seconds to exist in the first place? No. So this is not our answer. We don't want this answer. However, does the answer T equals 9.8 seconds make sense in the context of the problem? Would the rocket hit the ground in 9.38 seconds? Yes. So this is the solution we want. So of course, we're going to write our answer in a complete sentence. We're going to say that the rocket hits the ground in 9.38 seconds. All righty. So now what I want you to do, I'm going to get rid of my calculator here. Maybe it'll go away. Okay. So now I want you to do example 4. I think we just have example 4 left on your own. So you're doing a similar equation with h equals -16t squared plus 80t plus 2. You're going to find the max height. You're going to find when we hit our max height, and you're going to find when we hit the ground. Remember, to find when the rocket reaches the max height, you use t equals -b over 2a. When the rocket reaches its max height, you plug in T equals negative B over 2A. Whatever you find in part A, you're just going to plug in for part B. And then part C, use the quadratic formula. Your negative B plus or minus the square root of B squared minus 4AC all over 2A. All right, so go ahead and work on that. Press pause and then press play when you're ready to check your work. I'll see you back here in just a second. All right, let's go ahead and compare our answers real quick. So for part A, T equals negative B over 2A, I ended up finding that the rocket reached its max height in 2.5 seconds. Part B, I just plugged 2.5 back into the equation. For T, as you can see, when I simplified it, I got 102. So the max height of the rocket is 102 feet. Then I used the quadratic formula to find when my rocket will hit the ground. I just plugged in my B values, my A and my C. Then I got this equation, T equals negative 80 plus or minus root 6,528 all over negative 32. When I split it into 2 and simplified, I ended up with T equals negative 0.03 and T equals 5.03 seconds. Negative time doesn't make sense. Our rocket's not going to hit the ground after negative seconds. So the only answer that made sense in this case is the 5.03 seconds. So I know that my rocket will hit the ground in 5.03 seconds. All right, that's all for today. Go ahead and get started on your extra practice, and I'll see you back in class. Have a good day.